Hi folks, this is Steve here again doing another video on FreeCAD 1.0 for amateurs. Well, let me explain something first that I've not explained before. There are many very accomplished folks who do very comprehensive videos on FreeCAD on YouTube, like Mango Jelly and the Hardware Guy. And everything that I have covered in these videos, they've covered in far more detail. But I am not a professional. I am what I call an amateur. I'm a crafter. Therefore, particularly, I like to have things more simple. So folks like myself who aren't looking to truly dive into the intricacies of 3D modeling can kind of just make parts for their crafts. So that's what these are about. So this review today is a bit on Boolean operations in CAD. Boolean operations are simply the process of taking two or more bodies and parts and creating a new body part or a new body. And you can either have a fusion, a union of two, you can subtract one from the other, which is a cut, or you can only have the intersection of those parts. Most commonly, Boolean operations in FreeCAD are done either in the part design or the part workbenches. Now, in the part design workbench, which we're going to start off with, certain cut types of Boolean operations are simplified into a single operation using what they call subtractive primitives. All right, let's get started, and I'll make more comments as we go along. Here we are in FreeCAD 1.0 on my Mac, and we're in the part design workbench. Now, just for simplicity, we're going to just add some basic primitives to make the point I want to make. So we start here, and we don't have a body defined. So let's go ahead and just add a box primitive. Let's make it a little bigger, maybe. Okay. Now, I want you to notice that even though we had not started by creating a body, which is the normal way that you start in part design, I went ahead and just added a primitive, but the part design workbench added the body anyway. Okay, so now we have a body, and we'll call that body a box. Okay, now for some reason, let's say that we want to take away part of that box with a circle, with a cylinder. Well, you might say to yourself, let's go ahead and add a cylinder. Okay, and let's make this cylinder a little bit smaller just for the heck of it. There we go. Okay. Now, I want you to notice what happened here. We did not create a second part, did we? We simply added the primitive to the active body, which is the box. You can see it's the active body because it's checked. Now, I want you to notice here that these two already appear fused, right? There is no line separating the two. It is as if adding another primitive to the part called a box created an already fused body. Okay? Now you can highlight it perhaps. Yeah, you can kind of highlight it and see it. But the bottom line is you don't see a distinction between. If you tried to subtract or use a Boolean operation and remove the cylinder from the box, what would happen? Well, you select the box, you select the cylinder, you hit Boolean operation, and you get all manner of error messages. Okay? You simply can't do it. Boolean operations require, in the part design workbench, they require that each element that's going into the Boolean exists in a separate part. So let's go ahead and remove this cylinder. Let's create another part. And within this part, which is now the active body, let's create another cylinder. I'll just make it 5 millimeters. Now you can see in the tree that there are two bodies. One body is the box. The other body is the cylinder. I'm just renaming it. Now what happens if we try to do a Boolean here? And you can see that part design sees these as separate objects. In this case, we can make the box. Let's say we want to take away the cylinder from the box. Let's make the box then the active body, okay? And we want to subtract the cylinder. It tells us it's going to fuse, but we don't want to fuse. We want to cut. It's added the cylinder and the box, so let's take away the box. Well, it's not letting me do that. All right, we have to do it the other way. Sometimes it's easier, by the way, to combine, to bring the trees up. So I want to talk about this just for a second because it's not clear to me why this happens. But if I leave this tree like this, I can sometimes select the cylinder, but sometimes it selects everything and then it won't work. So I have found sometimes it's easier to collapse the tree, select the box as the active, select the cylinder, Boolean operation. Now the cylinder is correct. Let's cut it. And you see, in fact, that's what happened. Now I want to show what happens here. In Part Design Workbench, we have now used Boolean operations to cut the cylinder away from the box. You'll notice that the cylinder no longer exists as a separate body. It has been moved under the active body and renamed as Boolean. So now part design sees this as a single part. I'm going to go ahead and go back to where we were, where we had the box and the cylinder. Well, what if you wanted to subtract the box from the cylinder? Okay? Well, to do that, you have to make the cylinder the active body, highlight the box, go back to Boolean operations, box. We could fuse them if we want, but cut's fine. See? In part design for the Boolean operation, you define the active body to be the part that remains, and then select that which is being subtracted out. Okay, I hope you followed me on that. So let's go back. Well, I mentioned in the introduction that there are these subtractive primitives which function the same way as a Boolean cut. Well, let's show how that works. I'm going to take the cylinder, get rid of the cylinder. I'm going to go ahead and make the box the active body. And now I'm going to add to the box a subtractive cylinder. Let's go ahead and make that 5 millimeters again, just for the heck of it. See? In this particular case, the subtractive element actually stays within the active body, and you have a Boolean cut. Okay? So subtractive primitives remain under the main part that you've selected. Okay then, let's go back to having, I'm just hitting Command Z, by the way, to bring us backwards to where we had two active bodies, a box and a cylinder. Let's make the box the active body again. If it hasn't already, it is. Select the cylinder, and I'll demonstrate up here that when you do the intersection, what they call common, it's that part which remains, which is common to both. Okay, Command Z, come back to where we were. Now, what about Boolean operations in part design? In part workbench. So now we're in the part workbench. You still have your Boolean operations, but they spell them out a little better. So here we got the box as the active body, cylinder. We have union, cut, union, and intersection, just like we do in the part design. See? But as opposed to part design, where it collapses into the active body, in the part workbench, it creates a new part, the cut. Okay? And within the cut, you see the two parts. And that has to do with the way that the part design workbench works differently than the part design workbench. Okay, so I'm going to go ahead and go back to this. I'm not sure that I want to talk about anything particularly else in this video. Very, very brief. You're going to find, though, that, as I said earlier, you will run into trouble if too many elements in the tree are selected. Go back to the model. So, for example, if you try to select this box and then you try to select this cylinder, other things are brought in. By the way, that's using the Shift key. And you'll see what happens here. You want to try to cut, and you can't really remove, at least I can't. Okay? So I want to give you another hint. Don't use the Shift key. If your trees look like this, and you want the box to be the active body, and it is, and you want to select the cylinder, don't use the Shift key. The Shift key will select everything above. Use instead, select your Command key on a Mac, the cylinder, and now it will work. Okay? So that can confuse you if you use the Shift key to select two things that are separated in space. Because if you bring these other things in, the Boolean operation will fail. All right, well, I think that's all I want to say about here. And if you want to hear more about this, just let me know in the comments. All right, folks, thanks. Bye.